All right, so we are going to start our next lecture, which is on percentage. Now, remember the last couple of lectures we talked about the fractions, decimal fractions, right? Now here we'll first learn how we can convert from decimal to percent, okay, and also percent to decimal, because the percent is also pretty much close to decimal, because there is, you know, every decimal number can be represented as percent as well, okay. Now again, you know that the percentage means that every number is represented as a number followed by a percentage sign, right? Now when you have a decimal and you are trying to convert to a percent, you pretty much move the decimal point to 2 positions to the right, and then place and the percentage sign after the number. Okay, for an example, if you have 0.7 and you are trying to convert it to percent, just move the decimal point 2 positions to your right. Now you know that you can assume that there are infinite amount of zeros after any decimal number, because all the zeros are insignificant, but you can assume there are infinite number of zeros. So even if the number is 0.7, you know that there are infinite amount of zeros after 7, okay? You know, you can take as many zeros as you want. So you can just move the decimal point 2 positions to the right, which actually makes it 70, right? And followed by a percentage sign. So pretty much that's what I can do for every number. I'm saying every fraction you have. And similarly, if you have a percent and you have to convert it to decimal, so first remove the percentage sign, and then you actually move the decimal point 2 positions to left in the similar manner, okay? So again, when you move the 2 positions to the left, for an example here, this is 3, right? So usually the percentage sign, I'm saying the decimal point is after 3, right? Right after 3. So if you have to move it to the left and 2 positions left, so you can assume there are infinite amount of zeros at the beginning of the number. Because you know that all those zeros are insignificant, but you have infinite amount of zeros you can assume at the beginning of any number, which are insignificant, right? But you can just move in that manner, you can move the decimal point 2 positions to the left, right, to make it 0.03. And I think this is very easy because you have just decimal point here right after 0. You move it 2 positions to the left, which actually brings the decimal point at the beginning of before 7, right? Okay, let's try a couple. Yeah, this is like a summary of all the conversions. Okay, so that means if you actually know any of these, meaning if you know either percent or decimal fraction or fraction, you can always convert from that to the other two, okay? So for an example, let's say if you are given the decimal, okay? So you can move the decimal point 2 positions to the right to make the percent, right? You can also make the decimal to the fraction. You know how to do this, right? Remember, you actually write 125, and the bottom you write 1 followed by 3 zeros, because there are 3 decimal point after 3 decimal digit after decimal point, right? So you can do the same manner. If you have the percent, you can always go to the decimal just by moving the decimal point 2 positions to the left, right? And once you know the decimal, you can write the fraction, just writing 755 dividing by 1000, just to 1 followed by 3 zeros, right? And regarding the fraction, this is if you are given the fraction, you can divide 5 by 8, right, to get the decimal fraction. Once you know the decimal fraction, you can easily change it to percent, just moving the decimal point 2 positions to the right. I'm saying if you know 1, you can automatically, you should be able to convert to other 2. Let's try a couple of quiz questions. 33%. What is the decimal? 0.33, right? Let's look at the next one. 5%. If you move the decimal point 2 positions to the left, that becomes 0.05, right? 110%. 1.1, right? Which is B. See here, you could have written 1.10, but that's the same thing, because as we know that if you have zeros at the end of decimal fraction, those are insignificant. So that's why we don't write zeros, but it's the same thing if you write. Okay, 0.15. What is the percent if you convert it? 15%, right? If you move the decimal point 2 positions to the right. So the right answer is D. .75. If I convert it to the percent, that becomes 75%, right? 2.0. This is a whole number, but if you convert to percent, it becomes 200, right? 200%, because you move the decimal point 2 positions to the right, assuming that you have zeros, right? Right after the decimal point. So the right answer is C. One. 100%. %. If you convert it to fraction. Now if you convert it to fraction, it becomes 25 over 100, but you always know that you can always reduce it, right, if possible. So that becomes quarter, right? 1 over 4. Right answer is B. Right? If you have 25 over 100 and you just break 25 and 100 into prime factors and then cancel out, right? 50%. Half, right? Right answer is C. 33.3%. 1/3, right? So the right answer is D. Because if you move the decimal point 2 positions to the left, that becomes 0.333, right? And then you can write 333 over 1,000. Now, this is pretty much, because 1,000 is pretty close to 999, right? So that's 1 over 3. $300. If you convert it to fraction, right? You move the decimal point 2 positions to the right, which is 3, right? That means actually 3 over 1, because you can always assume that you have a denominator of 1, right? Even if you don't see any denominator in the whole number. So the right answer is B. Okay, let's try to solve some basic percent problems. So to solve some percent problem, we use 3 different terms. One is called base. In any basic problem, you will see some total or original amount. Usually the word of is in front of base. That's how you identify the base. The portion is actually the fraction of the base. But remember, the portion may be larger than base. I'm saying most of the time we think, oh, it's a portion, right? So it will be smaller. In some cases, the portion can be even larger. So portion can be larger, portion can be smaller than base. And the last one is rate, which is pretty easy to identify in the problem because the rate always is followed by a percent sign. Okay, if you know this, this three term in the most of the percent problem, you will actually have these three terms. So what happens is you will be given any two out of these three. Okay, and then you will actually have to identify the other one or find the other one. So what we do is we actually identify what are given out of these three. Again, as I said, out of these three you will be given two, right? Any two. And then we will actually do the math, substituting the quantities in a formula. Now here is the formula. So the formula is P equals to B times R. Now remember, the same formula we can write in different manner. It's actually the same formula. We just wrote in three different formats based on what is unknown. For an example, if the P is unknown, we use this formula. If B is unknown, we use this formula. We use R is unknown, we use this formula. It's actually the same formula. We wrote the same formula in tweaking the variables, changing their sign. Okay? And just make sure if you know which one is unknown, you actually keep that at in the left side, isolated. That's it. Okay? So let's try some problem. Now for example, here in this question, what percent of 120 is 24? As you can guess, 120 is following by of, so it's likely that this is base. 24 is the portion because the rate is missing, right? Because there is nothing followed by the percent, followed by percent sign. So the base is missing, rate is missing, so you actually have to find the rate. So you'll be using the formula for rate, which is R equals to P over B, right? So once you divide, you got 0.2. You will get actually answer as a fraction, decimal fraction, and you convert the decimal fraction to percent. That's how you get the rate, right? In this question. Any question here? No. Let's try another one. Okay, a box of 240 screws was used to install drywall. If the job is 75% complete, how many more jobs? How many more screws are needed to finish the job? Okay. Now, what is given here? More screws are required for a total. Okay, which is actually would be. That means pretty much the base is something you are looking for. Okay, so you are given the portion and rate. See, there is a little catch here, because even if we said that most of the cases the base is followed by of, but it's not every time. There are exceptions. Okay, because in this case you can look at from here that it said that 75% is complete. 75% of the job is complete by by 240 screws, because the 240 screws are actually the portion. Because if it is the base, then 100% job should be done by the base. You see what I'm saying? That's how you can guess that what is that. Okay. Now, so if this is a portion and 75% is the rate, we can use the formula for the base, which is P over R. We found the base, which is 320. So that means 320 screws you will need to complete the job. But the question asks, how many more screws you need? So we do a subtraction, right? Because we already have 240. We want to find how many more. So, just total is 320 subtracted. We got 80 screws that we need to complete the job. 25% more job to be done. Let's try a couple of quiz questions again. 20% of 60. Okay, first of all, what is base here in this question? 60, right? 60 is base. So right answer is C. What is rate here? Of course 20%, right? Right answer is A. So what would be the right formula to find? Okay, before that, what is the portion here? Unknown, right? We don't know the portion. So that means we will be finding the portion using the formula, right? What would be the best formula to find the portion? The last one, right? Because you see the last one in portion is at the left side isolated. So we'll be using D to find the portion. Okay. Now, what is the answer? The answer is P. Okay. How do you find it? The formula is P equals to B times R, right? Now, B is 60, R is 20%. Again, 20% means 0.2, right? Which makes it 12. 60 times 0.2. So the right answer is 12, right? That means that is your portion. Let's try another question here. What percent of 50 is 75? What is 50 here? Base, right? Right answer is B. What is 75 here? This is portion. This is interesting. As I said, remember the portion can be greater, larger than base, because the base is 50, right? But the portion is 75. Okay. So this is portion. Now the unknown is, of course, rate. Let's try the formula. So which formula we should be using? Of course, C, right? That's the formula for rate, and rate is isolated here at the left side. So R equals to P over B. If we use the formula, what would be the answer? P over B, right? That means 75 over 50. So right answer would be 150%, right? Because if we do P over B, it will be 1.5, and then if we convert that 1.5 into fraction, I'm saying into percent, it will be 150%. Right answer is A. So this is where you can see something interesting, because the percent is more than 100%, and that's why your portion was greater than base. Whenever the percent is more than 100%, your portion will be actually greater than base. Okay, right answer is A. Let's look at another problem here. 25% of what number is 40? Now, in this problem, what is unknown? Of course, base, because as you can see, the rate is given, which is 25%. Portion is also given, which is 40. So the base is unknown, which is B. Right answer is B, right? Okay. What would be the correct formula here? B, right? B equals to P over R. Okay. Now, if we use this formula, P equals to B over R, what would be the base? P over R, right? So 40 over 0.25, which makes it 160, right? So the right answer is C. Right? I'm sorry. Oh yeah, right answer is C. Yes, 160, right? Any question? Okay. Now we'll try some percentage problem to solve the tolerance problem. Now, a lot of times in the engineering equipments, we have some tolerance limit written on the equipment. Okay, so let's say it's written like 5% plus minus. that means that device can tolerate, because most of the time what do we, when we, let's say we have some electric equipment, okay, and it will be connected to the power, right, and it can take, let's say, 1 amp power. There is an adapter and it can change the, it can change the power, the current to 1 amp, but there is written like plus minus 5%. That means even if it is written 1 amp, but the current can be a little bit more than that, which is 5%, or a little bit less than that, which is 5% less, okay? Because in real life, most of the things are not exactly as accurate as we, think in theory, right? So that's why we actually try some percentage problem to solve this tolerance, issue, to see how much more or less any equipment can actually take, right? Find the range of tolerance by multiplying the nominal by percent. So the nominal means, again, as I said, the percent, find the maximum and minimum it can take, right? So for an example, what is the guaranteed value of a 27 kilo ohm resistance, where the tolerance limit is 5%? That means even if, let's say we have a register, okay, even if it is 25 kilo ohm, it may not give you exact 27 kilo ohm resistance. It can give you a little bit less or more. That means it can give you 5% more or 5% less. See, since the tolerance limit is written 5%. Now, if somebody wants to know what will be the range then, because it's not giving you exactly 27 kilo, instead it is giving you a range of resistance. What is the range? So all we do is we actually convert the 5% into fraction and then multiply that 5% with the 27 kilo. This is 27 kilo, right? To see the nominal value, right? Once you have that nominal value, you add the nominal value with the original amount to get the maximum, and you subtract it from the original to get the minimum value. So now you know this range. This is actually your range, 25,650 to 28,350. That's the range. So that means your resistance will work or will deliver resistance in between this range. You exactly don't know how much it will be giving, but you know this is the range it will be giving. Okay? So that's why the tolerance problem is extremely important. So now let's look at some tolerance problem here in the quiz section. So 250 feet plus minus 10%. So what would be the nominal value here? We try to find the nominal value first, right? That will be added and subtracted, right? So how do you find it? To find the, let's try the nominal value first. The nominal value is what? 250 times 10%, right? Which is 250 times 0.1. 10% means 0.1, right? And that makes it 25. Now the 25% is the nominal value. So that means to get the maximum, you'll be actually, because the question is saying what would be the maximum, right? So the right answer is D. Now look at the change between D and C. The only difference is in the C, you don't have any unit for the nominal value. Remember, in the engineering discussion, we always need the unit. So the right answer is D. So the maximum value would be what? 275, right? Feet. What would be the minimum? Again, 250 feet minus 225 feet. So the right answer is C. So now you know the range. The minimum would be what? 225 feet, right, in this case. Now let's look at another example, 200 meter plus minus 5%. And let's say we are trying to find the maximum, right? So first we find the nominal value, right? Nominal value would be what? 200 times 5% is actually 200 meter times 5%, right? Which makes it 200 meter times 0.05, which is 10 meter, right? So once you know the nominal value, you can add the nominal value, right? So the right answer is B, right? Because in the B, we showed how to add this. It's 200 meter plus, look at this multiplication, 0.05 times 200, which is actually how you find the nominal value, right? Because you can do it at once together instead of doing it in two steps. It's up to you. Okay? So the right answer is B. But if you do this math, you will get 210 meter as your maximum. And now the time for the minimum, right? 200 meter minus 10 meter, which is 190 meter. So the right answer is D. All right, so this is the end of chapter 4%. So now you can go to the quiz section and try your homework for chapter 4.